Hello everybody, and we'll be working on the exercises of section 3 of chapter 1 of Basic Mathematics by Serge Lang, the yellow book, and we'll be working on the exercises for about 30 minutes. So let's begin with problem 1, where we will have A, C, E, or A, B, C, D, E, F, so 6 parts to this question of 1, where we are being asked to express each of the following expressions in the form 2 to the m, 3 to the n, a to the r, and b to the s. Now, I wrote this little tidbit here, s, because if you look at it, that s, it's really hard to show it on camera, but that s looks like an 8. It didn't print well, but then again, it's really small. Like, it's incredibly small. We're talking less than 2 millimeter size. Well, if my pencil lead is 0.9, yeah, it's about 1 millimeter. I think it's almost exactly 1 millimeter, because it's just a little bit bigger than my 0.9 millimeter pencil lead. Okay, so let's express each of the following expressions in the form 2 to the power of m, 3 to the power of n, a to the power of r, b to the power of s, where m, n, r, and s are positive integers. So we have problem 1, a. We have 8 times a squared times b cubed times 27 times a to the 4th power in parentheses times 2 to the 5th power times a times b in parentheses. So, what can we do to get what we want? All right. So, normally I would get these explicits into the form of 2 to the m power and 3 to the n powers, respectively. So, 8 is an even number, and I know that 8 is 2 to the 4th power, I believe. Let me test that real quick. 2 times 2 times 2 times 2. Actually, to the 3rd power, not the 4th. Because 2 times 2 equals 4, times 1 more 2 equals 8. So 8 is actually equal to 2 to the 3rd power. A squared, b cubed. We're just going to bring these down. And then we have 27. Okay? 3 times 3 equals 9, times 3 again equals 27, so this can be written as 3 to the 3rd power times a4, a to the 4th power. And we have 2 to the 5th power. It's in the form of 2 to the m, with m being 5 in this case, so we're just going to leave it as is, 2 to the 5, and we have ab. Okay? And then let's organize this by using the rules of commutativity. So this is like by power, by powers, where 8 equals 2 to the 3, 27 is equal to 3 to the 3rd power, and, oh, that's actually just it. That's all we did. Sort of by powers and by, well, we could prove it, but I don't think we need to. It's sort of redundant. if you have your power sheet memorized in your head, like I don't, but at least you can work it in your head before you can go from here to there. It works enough. So as long as it's simple enough, you don't have to do so much explanation on the side. That will be my justification. Okay, so then let's organize all of our explicits to one side and all of our implicits to the right. So we have 2 to the 3 times 2 to the 5 times 3 to the 3 times a squared times a to the 4th times a times b to the 3rd times b. Okay, so then we know that we can use the rule. So this is all by associativity and commutativity. Of multiplication. Okay? So then we have 2 to the 3rd power times 2 to the 5th power times 3 to the 3rd power times a squared times a to the 4th power times a times b to the 3rd power times b. So then what we can do is, by the rule in the book mentioned at 11, where we have a m plus n is equal to a sub m, a sub n, but we want to swap this around. A sub m, a sub n is equal to a sub m plus n. Okay, so we're going to use this to combine ours over here. So we're going to use it here, where 2 is the a, and the 3 and the 5 is m and n, respectively. So then we're going to have 2 is equal to 3 plus 5. And 3 is just going to be on its own, so 3 to the 3, we're not going to do anything with it. And then we're going to have a to 2 plus 4 times a. Now I'm very tempted, very, very tempted to add a 1 here, so 2 plus 4 plus 1. But we're working with rules, step by step, very carefully. Okay, much more carefully than I believe we need to. Absolutely more carefully than we need to. But that's how I am progressing. So that's how we will progress. If it's slow for other people, well, speed up, I guess, or go past me. But I'll be here to help those who at least want to work similarly to me. So then we also have b to 3 plus 1, because b in itself is b to the power of 1. Okay then. So then we add these together, just simple addition. So 2 to the 8 plus 3 to the 3, unchanged. A to the 6 times a, and b to the 4. So that's by... Well, actually, I put these parentheses in there. I didn't need to have them there. But you could imagine that we did associativity to remove these parentheses. Hello, train. You know, I never noticed the trains until I start doing recordings. And then all of a sudden the trains matter. Okay. And then by n11 again, we have 2 sub 8, 3 to the 3rd, a sub 6 plus 1, b to the 4th, 2 to the 8, 3 to the 3, a to the 7th, b to the 4th. So then, we have our answer in the form that we were requested. 2 to the m, this being 8, 3 to the n meaning 3, being 3, a to the r meaning of 7, and b to the 4th being s. And we can see that m, n, r, and s are all positive integers in our answer. Okay. So we have completed problem A of exercise 1. So let's move to problem B. We have 16 times b cubed times a squared times 6ab to the 4th power in parentheses times ab in parentheses cubed. Okay, so then let's tackle this piece by piece. Okay, so then, well, we have this 3 outside of this parentheses. So let's distribute this 3, this to the 3rd power, to a and b. And how are we going to do that? That is by the rule. Where is the rule? Actually, I don't think there is a rule for that. Explicitly stated in the book, I don't think there is a rule. I guess we could apply N12 several times. But we do have it here in this book. Here we are. Now it's not explicitly stated as a rule. This, I guess, would be like N13. So like N12.1. We have this. So let's say N12.1, where a b to the n is equal to a to the n times b to the n. Okay, so then we can bring things down that we're not touching. 16b cubed a squared times 6ab to the 4th power times, in this case now, a cubed b cubed. Okay, and now by rules of associativity and commutativity, let's move these around. Alright, so then we have 16 b3. Hold on. Let's actually move things around organized wise. 16 times 6 times a squared times a cubed times b cubed times b to the 4th times b to the 3rd. Okie dokie. So then, how can we do this? So we know 16 is 4 times 4, and then if we split those 4s, there it's 2 times 2 times 2. So I believe, effectively right here, we have 2 to the 3rd equals 8 up here, 1 more, and we would have 16, since 8 times 8 equals 16. So it's 2 to the 4th power. So we can sort of use our powers here. So put this 2 to the 4th power. And then we have 6 here. Now how do we get 6? Because 3 times 3 is 9, and 2 times 2 equals 4, and 2 times 2 times 2 equals 8. So we're above in both counts. But what we can do is we could split this into 2 to the 1 and 3 to the 1, because 2 times 3 equals 6. Times a squared, a cubed, b3, b4, b3. Okay? And this is by powers, where 16 is equal to 2 to the 4th, and 6 is equal to 2 times 3, 2 to the 1, 3 to the 1. have that written off to the side. Ooh. I'm gonna sneeze. I'm alive. Okay. Alright. By n11, we're going to start adding these exponents together. So we have 2. Now, I'm going to say n11 extended. Alright. So that's going to be a to the m plus a to the n plus a to the dot 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 is equal to a to the m plus n plus dot dot dot. Alright? Now this isn't proven, but I'm just going to say it, and by assumption. Okay. So I can shorten it over here. So it'll be 4 plus 1 over here. Oh, wow. Oh, I know it's useful over here. 4 plus 1. Now, I like to put it in parentheses because if I write poorly, at least I know that it's together and also related to this 2, instead of accidentally writing a 3 like directly below it or just getting lost. So I add them for sort of writing safety. All right, now we got 3 to the 1, a to the 2 plus 1 plus 3, and then we have b to the 3 plus 4 plus 3. Okay, easy peasy. And then just by addition. So we have 2 to the 5th power, 3 to the 1st power, a to the 6th power, and then finally b to the 3 plus 3 equals 6 plus 4 to the 10th power. Alright, so here we are. We have the form of 2 to the m being 5, 3 to the n being 1, a to the r being 6, and b to the s being 10, m, n, r, s, all positive integers. We have completed problem B of exercise 1. How much time do we have left? 12 minutes. So let's move on to problem C of exercise 1. So we have 3 squared times 2ab in parentheses cubed times 16a squared b to the 5th power in parentheses times 24b squared times a in parentheses. Okay, so then, how might we do this? So let's use the distributive property of powers, I guess. I'm just throwing that words out there, but we know by n12.1 that we wrote before, we have a b to the n is equal to a to the n b to the n. Okay, so we're going to sort of distribute this n power into our components in the parentheses. So we're going to do that for our third power up here. So we'll bring down our 3 squared, and then we're going to have 2 to the 3rd power, a to the 3rd power, b to the 3rd power in parentheses. Now actually we could take those out of the parentheses. So we hit 2 birds with 1 stone using n12.1. Now if we proved n12.1, then we could use it without an assumption, but this is by assumption. Okay. Now, I did do a little bit of research into these n's, so n1, n2, n3. So it's sort of, well, at least apparently, that it is isolated to the Basic Mathematics by Serge Lang book. So these n rules, number 1, number 2, assume that's what they're meaning, are simply Serge Lang's writing system, of course. Writing system. So other people use like theorem numbers. Some of them don't use any of this correlation between a common relationship and a sort of a mapping of a term to it. Some of them don't even have it. They just have this. Or they just have associativity or commutativity. And so I was hoping that these N system was sort of like an ISO standard, you know, like an ISO 1121 or whatnot. I'm just throwing numbers out there. But I was hoping that there was a organized list of what rule is being talked about. Now, I don't quite think it makes all that much sense, because we do N12, N1, N3 makes sense. It's a lot easier to say than a b to the nth power is equal to a to the n to the b to the n. It's a lot easier to say N12.1. But it does start losing meaning, because now we're focusing on how we map this and then memorizing this instead of actually this, which is the most important thing to memorize. So that's what the N system is, at least. That's what I was able to research out. So it's isolated to this book. I was hoping for it to be a more third-party organized affair, but it's not. But okay, perhaps I'm wrong about that. Please let me know in the comments if there is a organized system, or at least an attempt to be an organized system of organizing these proven or straight-up assumed properties of mathematics. So, outside of that tangent, we have distributed our third power into 2ab, and we're going to simply leave everything else as is, because we want to make sure that our writing over here makes sense. And I will begin to less repeat myself when I'm talking about these problems. So instead of me saying these as I write them back down, I'm just going to drop them down and assume that you understand what I'm saying, or what I'm lacking saying. Okay. So then, let's do by powers. 16 is equal to times 2 times 2 equals 4 times 2 equals 8 times 2 equals 16. So that's 2 to the 4th power. And 24 is 16. It's not 16 times 2. So we can have 24 is equal to 16 times... It can't be 3 either. Oh, it's 12 times 2. I'm trying to figure out how to split 24. Oh, well, that's easy. 8 to the 3rd power, or 3 to the 8th power? No. What does 24 equal in powers of 2 and 3? Eight to the 3rd power. So we want 2 to the 3, which is equal to 8, times 3 to the 1 times 3 equals 24. Here we go. We're using our brains now. So then we can replace those. So we state these that have gone unchanged. And then replace these. 16 by 2 to the 4. Now we're substituting it because they were equal. And we can, because they are equal. Then we have the product of 2 to the 3rd times 3 to the 1st equals 24. Okay. So now we have everything written out in sort of the mixed forms, but of the forms that we're looking for. So 3 to the powers, 2 to the powers, a to the powers, b to the powers on their own. So then, by rules of associativity and commutativity of multiplication, we're going to start moving all these things around. So what form do we want? We want the form of 2 to the m, 3 to the m. So let's start with 2 to the m. So then let's bring 2 third, 2 cubed down, and then 2 to the fourth, then 2 to the third, and that ends our 2's. And we want to times this by 3 to the second, 3 not cubed, 3 squared, times, well, 3 to the 1. That ends our 3's, and then we want, well, it's actually right here. So we have 2's, 3's, A's, B's, A, B's. Okay, so let's do our A's. So we have, starting from the left, going across, we have A cubed. Now, and I was doing something nice here. I was putting a dot in between, because a dot and no dot mean the same thing in this circumstance. A3, and then, okay, we got A to the 2, second power, and then we finally have A to the first power. Okay, and then we want B's. So let's put a dot here, and we got B to the cubed, B to the 5th power, and then B to the 2nd power. Okay, so we now have it nice and organized, and we're going to use our by n 12.1. We're no, wrong rule. All right, by a sub m, a sub n is equal to a sub m plus n. Now, what rule is that? Now, I'm just doing that off memory, which I really like that I'm able to do. That is N11 on page 18. All right, and then we have N11 extended that I mentioned, MN, AN, and I'll write ... is equal to A, M plus N plus ... Okay. Extended by assumption. Okay, so we're going to apply this rule. So we have 2, 3 plus 4 plus 3 times 3 to the power of 2 plus 1 times A to the power of 3 plus 2 plus 1 times B to the power of 3 plus 5 plus 2. And now, because I have these dots adding a little extra spacing, I'm not going to put my parentheses up on top, as I normally do. So see, I can change how I do things. I'm not totally rigid. Okay, let's finish this up quickly. Now, the timer's about to go off. So 3 plus 3 equals 6 plus 4 equals 10. So 2 to the 10th power times 3 to the 3rd power. 2 plus 1 is 3 times A to the 3 plus 2 equals 5 plus 1 equals 6. And then finally we have B, which is 3 plus 5 equals 8 plus 2 equals 10. So we have 2 to the 10th, 3 to the 3rd, A to the 6th, B to the 10th. And so that's 2 to the M, M being 10, 3 to the N being 3, A to the R being 6, B to the S being 10, and M, N, R, and S are positive integers. So we are finished. Problem C of exercise 1. I'll stop it here. 30 minutes of recording, 3 problems done, 10 minutes on average for each problem. We're moving on to the next video where we will continue with these exercises. Thank you.